104 maximum depth of binary tree. So in this question they have asked us to just give the depth of the binary tree, the maximum depth of a binary tree for the given root node. So suppose we have given a node like this, like 3, 9, 20 and 15, 7, then the depth will be 3 because it's 1, 2 and then 3. So it's 1, 2 and then 3. So we can solve this question using different approaches like DFS or BFS, that is depth first search or breadth first search. In the DFS we can use three algorithms like pre-order traversal, post-order traversal or in-order traversal. And also in the breadth first search we can use a queue and do a breadth first search accordingly. But another algorithm that we can use is also called as Morris traversal, which is using O of 1 space and O of 3n of time, which is optimized version of every traversal. But here we are not using that because as you can see the question is marked as easy and it would be a warm-up question for your interview, so you can just use a DFS algorithm and give your solution to the interviewer. And then let's jump to the algorithm. So what we are going to do is we are using post order traversal. So essentially we will be going to the left first, then we will going to the right first, and after going to left and right we will get the maximum depth and then add 1 for the current node to it so that the depth will be increased. So suppose for 3 we will go to 9, for 9 we will go to this left side here, and for 9 we will go to right side. As there's nothing, so it will return 0, and as it's returning as 0 then I can add 1 to it, so here the depth will be 1. And when I go here this have returned 1, 2, 3, and now when I go to right and then left and then left, so 15 will have 1, 7 will have 1, they both return 1 to 20, 20 will add 1 to max of them, the max of 1 and 1 is 1 only, and after adding 1 to it, it would be 2, so the height of the 20 will be 2, 20 will return 2 to it, 2 to 3, and after returning 2 to node 3, the node 3 will compare what's the maximum between 1 and 3, the 1 returned from 9 and 3 returned from and 2 returned from 20. So we can see that 2 is max and then 3 will add 1 to it and it will be 3, so the depth will be 3. So we are coding up this solution. To code this solution, first of all what we will going to do is if root equal to null, then just return 0, and the left will be equal to max depth of roots left, as we are going to the left hand side of a tree, and similarly the right will be equal to max depth of roots right, and I'll just return max of left and right along with 1. If I try to submit it, it will work, it must work, and yes, it's working. If I submit it, it will work. And what is the time complexity of this algorithm and what is the space complexity of this algorithm? It's nothing but for the time complexity it's O of n, because we are traversing for every node, so we are traversing each and every node in a tree, so it's O of n. And for space complexity it will be O of h, where h is the maximum height of a binary tree. So I hope you understood the solution. If you understood the solution, just like the video, don't forget to subscribe the channel, share the video with your friends who are stuck up in this problem. I'll see you in the next one. Thank you very much.